So in this video, we're going to be looking at finding reference angles. So I have this first one. I have that theta is equal to 5 pi over 3. And so that is written in radians. So my first step is I'm going to go ahead and draw this angle because I need to figure out what quadrant it's in. Because what quadrant it's in is going to tell me how I find my reference angle, because that's going to be either of these three options up here. So I have 5 pi over 3. I'm looking at radians here, and so this is pi over 2 pi, 3 pi over 2, and 2 pi. So first this has to be between pi over 2 and 2 pi, and I see it is because 2 pi would be the same thing as 6 pi over 3. And so I need to figure out where it's at, and one way I can see that is if I add a pi over 3 over here, I get 6 pi over 3, which is the same thing as 2 pi. So it's a little bit less than 2 pi, so that means it's going to be somewhere over here. And so that means that my reference angle is going to be this angle right here. So since I am in quadrant 4, that means I'm going to be using this equation here. And so this tells me that theta prime is going to be equal to 2 pi minus theta. So I have 2 pi minus 5 pi over 3. And when I do that subtraction, when you get a common denominator, you get that the reference angle is pi over 3. Okay, let's look at this next one. So this next one, I have negative 130 degrees. So my problem with this one is the fact that it is not between 90 degrees and 360 degrees. It is negative. So I need to actually find a coterminal angle to this one. And so since this is negative, I want to make it positive. So to do that, I can just add 360 to it. When I do that, I get 230 degrees. And so drawing this angle now, I need to figure out what quadrant it's in. So I'm in degrees, so I know that this first one is 90, 180, 270, and 360. So 230 is somewhere between 180 and 270, so it's going to be somewhere over here is my theta. And so that means my theta prime is going to be this angle right here, and it's in quadrant 3. So I want to look at my quadrant 3 equations here, and that tells me that theta prime is equal to theta minus 180. Well, my theta here is 230 because, again, I had to change it over to being positive. And when I subtract those, I get that theta prime is equal to 50 degrees. And so the reason why I can use a coterminal angle is because we learned before, coterminal angles have the same terminal side. And so that's why it's okay if I do it with a coterminal angle. Okay, now let's look at this next one. This next one I have theta is equal to 15 pi over 4. So first I'm going to see if it's in my range, and I see my range, it's pi over 2 to 2 pi. Well, if I do 15 divided by 4, that's going to be greater than 2 pi. And so that means I need to find a coterminal angle. So I want to go ahead and try subtracting by 2 pi. So if I subtract by 2 pi, that's really the same thing as subtracting pi, 8 pi over 4. I get 7 pi over 4. And so now I need to draw that angle. Well, 7 pi over 4, I see that's really close to being 8 pi over 4, which is equal to 2 pi. And so that means it's going to be a little bit less than 2 pi over here. And so I see that this angle is, again, in quadrant 4. So looking at my quadrant 4, I see that that is going to be theta prime is equal to 2 pi minus theta. So I get 2 pi minus 7 pi over 4. And when I subtract those, I get that theta prime is equal to pi over 4. Okay, let's look at one last one. So here I have theta is equal to 110 degrees. I'm going to first check to see if that is in my range. And I see that theta needs to be between 90 and 360. 110 is between that, so I'm good. So now I want to go ahead and draw that and figure out what quadrant it is in. Now this is 90, 180, 270, 360 degrees. And I see that 110 is between 90 and 180, so it's going to be somewhere over here. So that means that my reference angle is in quadrant 2. So looking at that, that means that theta prime is going to equal to 180 minus theta. And so I get 180 minus 110. So that means that theta prime is equal to 70 degrees.